Now let's look at another uh, perspective of analyzing this graph here. So we know that the velocity displacement relationship in this context is a circular curve here, which is centered at a comma b, and assuming that this is 0 comma 0, if we go x minus a the whole square plus y minus b the whole square is equal to 1, need not be 1, right? Could be any value for that matter. So let's take is equal to r square, right? Is equal to r square is equal to a constant maybe. Now, since this is centered at origin, this becomes x minus 0 the whole square plus y minus 0 the whole square is equal to r square, which is x square plus y square is equal to a constant. Now, this graph is also called as a phase space graph or a state space graph. And our problem statement here is to identify if this is a if this graph represents a one-dimensional motion or not. So we have a graph with y-axis as velocity with meter per second and x-axis with displacement in its unit meter. Why am I talking about units all of a sudden? What could that be? Exactly, dimensional consistency. Look at this. The equation is v square plus x square is equal to constant. V is meter per second. This becomes meter square per second square plus x is meter square, which simply implies that this given equation is dimensionally inconsistent and therefore another reason to reject this graph, if that makes sense. Okay. Right. Now, you might be wondering if dimensionally inconsistency of a equation or of the given curve matters, what about in simple harmonic motion? So is that equation wrong correspondingly? Let's spend some time to understand that. So we know by law of conservation of mechanical energy, for a simple harmonic motion, kinetic energy plus potential energy is constant, which means half mv square plus half m omega square x square is a constant. Dividing this equation throughout by m and 2, what we get is v square plus omega square x square is a constant. The dimension of v square is m square by s square. Dimension of, okay, this might be tricky. This part here. Dimension of omega square x square is, unit of omega is radian per second. Displacement is meter. So this becomes meter square per second square. And since omega is a dimensionless quantity, the dimension of this term becomes m square by s square. Now this equation is dimensionally consistent. Not clear? Let's spend some more time. For a simple harmonic motion, if v square plus omega square x square is equal to a square omega square, if we divide this equation throughout by a square omega square, v square by a square omega square plus omega square x square by omega square a square is equal to a square omega square by a square omega square. Well, this constant is actually a square omega square. Okay. So this equation, v square by a square omega square by omega square is 1. This is x square by a square by a square is 1, omega square by omega square is 1. So this is the new equation for simple harmonic motion. Right? Now, what does this equation represent mathematically on a graph? Does it represent a circle or does it represent an ellipse? What do you think? Circle or ellipse? What is the equation of circle? What about ellipse? Or r square? My bad. 1, right? Now, which one would this equation fall into? This here or what do you think? So, if we compare this with the standard equation of an ellipse, equation of a standard ellipse, what we get is y square by b square plus x square by a square is equal to 1. Therefore, by comparing these two equations, we can say that x squared, a square, that a is equal to capital A, which is the amplitude. Maybe you can write this as along the minor axis and along the major axis, A is equal to capital A, the magnitude, the amplitude, and V square, Y square, B square, A square, omega square. So B is A omega, A times omega. Okay. Now, if you have paid attention to what we were discussing during the concept, we did mention what is A and B, and we also drew it along with that, right? So we will have to spend some time to understand how would it change the graph if the value of A and B would vary. Okay. Now, all the other concepts that we discussed that remain the same. We just wanted to introduce something more regarding the dimensional consistency. Okay. But there was some element of confusion when we were discussing the scaling pattern, right? So how do we scale? That's all been discussed. Now let's see what happens when scaling takes place. So if B is greater than A, if this, this major axis is greater than the minor axis here, the ellipse will stretch along the y-axis. Maybe I should write it down here. Ellipse stretches how? Stretches along the y-axis. Now, what will happen if this turns the other way around? If A is greater than B. So if A is greater than B, what we see is the ellipse will now turn stretching along the what? Stretching along the x-axis. So the ellipse will stretch more along the x-axis like this. So this is A here, and this aspect is B. Now, the moment we say A is less than B and A is greater than B, what else should come into our mind? Exactly, what will happen if A is equal to B? Let's write down the equation as well. So we have x squared by A squared plus y squared by B squared is equal to 1. And the question is, what will happen if A here is equal to B? So rather it becomes x squared plus A squared by x squared plus A squared is equal to 1. Maybe I just write it down one more time. So this equation changes as x squared by A squared plus y squared by is equal to 1. And B is equal to A. So this is x squared again, which gives us x squared plus y squared is equal to A square. And what is x square plus y square is equal to A square imply mathematically in terms of graph? Exactly. It implies that the ellipse has now become a circle where A is equal to B And this is what we were discussing in the concept of scaling, making an ellipse into a circle, thereby defining new axes as well, x and y. How did we define x and y? That was in the previous solution. Hope that makes sense. Okay. Right. So what's the previous solution? Pause the solution here. Watch the previous one. Make notes of it. Come back to this one more time. Draw it on your own. Understand what is A, what is B, what how would it change the graph when A is less than B, A is greater than B, A is equal to B. What do we have the given equation in the form of a simple harmonic motion? Is it an ellipse? Is it a circle? How can we make an ellipse into a circle? Scaling. What is scaling? How do we divide it? What is the new terms? What are the new dimensional? What is the new check for dimensional consistency? Think of these things. Write it on your own, and I'm pretty sure you might have some, um, you know, um, questions regarding this. Please feel free to ask it. I'll be more than happy to explain that one more time or that question in particular. Okay. Moving on to the next graph. Oh, which is the one based on velocity and time instead of velocity and displacement.